Okay, so welcome to the CompTIA two core based exam, 2201101 and 2201102 exams. So we're still looking at some of the components. Like the CompTIA exam is based off you understanding the different components of your PC and to see how you can provide support for tech users. So tech users might be using PCs, they can be using mobile, they can be using networks, they can be using any of those IT infrastructure, can be printers, can be all of that. So that's why you see the exam is typically an entry-level exam. The training is an entry-level exam for you to understand tech, understand the gadgets you have in tech. Because if you are going to do advanced stuff like cybersecurity, digital forensics, it still falls back to these hardwares. If you want to do networking, it still falls back to this hardware. If you need to do cloud computing, it still falls back to this hardware. It's only when you're doing soft skill based kind of stuff that you might not have to do with most of this hardware. So the exam covers areas like printers, desktops, tablets, wireless, mobile, all of that. Okay, in the previous training, we stopped at 110. So let's look at port replicator. I think we've exhausted that. This is docking station. So docking station would normally be an item attached to the PC, to most likely under the PC or via a port, whereas a port replicator is just going to be something that is not going to extend, something that is not going to give you multiples of. For instance, you have a USB.
Yeah.
USB replicator. You have a USB, one goes into the system, then you now have 4, 5, 6, right, is going out to either maybe provide memory card slot, to provide USB slots or whatever. So that's what you call a port replicator. So in the exam, you're going to see scenario-based questions that have to do with you having a challenge. The PC or the tablet or the laptop have just maybe 1 or 2 ports, and you need to maybe connect printers, connect this, connect that. What will be the mostly likely option for you to be able to solve that challenge? Because the job that it's going to come when you have this training and certification is that to actually solve problems, to solve business problems, to solve tech problems associated with most of these hardwares. So you see that your answer is going to be having a port replicator, because if you put this main one into the PC, you have options of connecting other items. So that's what you call a port replicator. So it's a device that allows the laptop to expand the number of ports. Ports to mean it can be USB, it can be DVI. DVI is the older form of video. It can be the Ethernet. It can be any port, right? So you cannot be able to attach devices such as printers, cameras, mouse devices, speakers, and so on. So the term docking station and port replicator are often used interchangeably. There's a difference, however. A docking station provides proprietary connection to device. Proprietary connection will mean things like power, like Ethernet, like USB, those core ones. Whereas port replicator provides industry standard connections such as USB, HDMI, and connectors. Proprietary is going to be those ones associated with that particular system. Okay, you have another objective in the exam: configure basic mobile device network connectivity and application support. Now, if you see the way the exam is constructed, the exam is constructed in such a way that they have objectives. So this outline is based on the objectives, right?
Okay.
Given the scenario, configure basic mobile device networking, network connectivity, application support. Now, if you have a mobile device, how do you connect to the internet? How do you do Bluetooth? How do you do wireless? How do you do hotspot? That is what this particular module is after. Now, you have 2G, 3G, 4G, 5G, right? So basically here, you want to know the different generations in terms of things that are going to differ in speed. They're going to differ in the distance they can cover and several other characteristics. So you want to be able to understand those characteristics. Older phones are going to be this compliant. New phones are going to be this compliant. LTE, that word is called long-term evolution. And most of the times for the exams, you're not going to see a word that is going to not be a word that is abbreviated is always going to be in full. So it's not about cramming, it's about understanding, right? So this is going to differ slightly for some phones. This is not much of a big issue. How do you activate or set up the network that you want to use on a particular system, rather on a particular phone? So cellular, if it's an iPhone 13, select voice and data, select 5G. If it's on an Android, you go to settings, mobile networks, select your preferred network. At the times you can scan, or you can just put it on auto mode. Enabling and disabling hotspot. So you use hotspot to like extend the connectivity you have on the mobile to several other devices. To use the mobile hotspot feature on an Android, these steps can be followed. This is for a Samsung. So you enable hotspot feature on the device setup. You select how you want to share the connection. It can be the SSID. SSID is your identifier, which is like, it can be the name you want to use. And of course, a password, so you can reset your password. Know that every item, every wireless Ethernet is going to have a MAC address. MAC address is also called physical address, right? It's something like this. You switch it on. Step 2, you give it a name that you want people to identify it. This is always very, very ingrained on the device. So that's why it's called physical address. So this is not something you can change. So you can change the name. Then the last thing you want to do is to I think at this point you're able to start seeing, you see the different instructions on how to use it. Of course, at the other end, you can turn on your Wi-Fi. So here, what you're going to be turning on is hotspot, I mean. Then on the device, you're going to turn Wi-Fi. Then, of course, you're able to connect. This is what we do every day. Now, how do you find the MAC address on a PC? So you normally say ipconfig all. If you say ipconfig, you are just going to know CMD, command prompt. Can you see my command prompt? Can you see my command prompt?
Yeah.
Good. So if you say ipconfig, you are going to see an abridged version of the IP configuration of the system. You're going to see the different adapters I have. 1, 2, 3. If I go to Windows E and go to network, or I just say system or network adapter. Let me say network adapter. Manage network adapter. This brings me straight actually. So let me just go there. Manage network adapters. You're going to see all the adapters you have on the system. So you have 1, 2, 3, 4, 5. This is by my virtualization softwares I use for cybersecurity. This is for my VirtualBox. I have a VMware software, which is this one. I have a VirtualBox, which is this one. Then I have my Bluetooth and my Wi-Fi. So I don't have Ethernet port. This system does not have an Ethernet port. So newer systems most likely don't have. Older systems do have. It's just the idea to make things thin, to make things slightly slim. So I have 1, 2, 3, 4, 5 adapters. So this might not show, but 1, 2, 3, 4 is going to show. So that's what you're seeing here. 1, 2, 3. 1, 2, 3. So I don't know why the fourth one is not showing. Okay, maybe the one for the VirtualBox is not showing. So the one for the VirtualBox is not showing, but 1, maybe 2, 3, they are all showing. So you can see all the adapters on the system. Now, this is the one I'm currently using, right? So that's why you see it as an address. So you cannot have an IP address if you are not connected to a router. So the difference between a switch and a router is that a switch is a device that is like to forward packets. Packets are units of data from one point to the other, whereas a router is a device that is going to help you connect 2 networks or more. So my router is not helping me to connect to the internet. So my router is going to give me an IP address. So if you're not connected to a router or a layer 3 switch, you cannot have an IP address. So this is my gateway. I can put this here. And I'm going to see which gateway I'm connected to, right? 192.168.1.1. Also, I can see the IP address it has assigned to me. So here to here is going to be always same for all the devices, right? This is going to be the different item. So this is my router, my gateway. This is my own person. If another system connects to that router and you check, it might give it another number, right? Now,
121.122.
yeah, it's good. But when I say IP config, it gives me a whole lot of details /all. It gives me everything that is I have on the IP config. So if I tap, I'm going to see quite a lot of information. It's going to tell me what's the name of this system. It is Southern founder. What's the node type? It's hybrid. IP routing, no enabled. Windows proxy enabled, no. The first adapter, though it doesn't have an IP address, it's telling me that this is my Microsoft Wi-Fi direct virtual adapter. So this is going to be by the virtual box. The second adapter is going to tell me is by the virtual box. This one LAN Wi-Fi. So this is the one I'm using to connect. So it's giving me the name, giving the IP4 address, the IP version 6 address, 4 address when I connected to this system first. Since I connected to the router, it's going to tell me my version 4 address and my version 6 address, right? This is the if you did CCNA one, or when you started networking, you understand the difference on how this was compressed to this, right? Now networks over TCP/IP enabled. So it gives you detail about the IP configuration you have currently on this system. That's different between IP config and IP config /all. So all is a little bit more detailed. So command IP config /all to see the MAC physical address for the device. So that's just about that. So caution, some cellular providers charge an additional fee if you turn your cellular device into a hotspot or if you are using tethering yet. Most developed parts of the world, you could be charged depending on the number of devices that you connect to, or you are charged per bandwidth, or you are charged per month, depending on how the charge happens.
Okay.
Now, some people say, okay, my hotspot or my Wi-Fi card is bad. How do I still connect? Make sure that I can be able to connect my phone. I can use my phone to connect to the internet via my laptop. So you use what? USB tethering. So if you go to your iPhone or your Android phone, just connect the USB cable. Make sure that you choose on USB data. Then it's not just power. Don't forget, I've already explained in the previous training that your USB have 4 cables. True or false?
True.
So you have data, you have power. Data is 2 points, positive, negative. You have power is 1, then you have F. So you want to make sure when you're connecting the cable, data is switched on. It's only when data is switched on that can work. If you choose power, I just want to charge the phone, you cannot do tethering. So it has to be data. So you have to make sure you choose data. Then, of course, you go to the phone in the hotspot, in the Wi-Fi session, in the hotspot session, and choose USB tethering. Once you do that, automatically the Windows computer will start browsing. Now you have GSM and CDMA. So CDMA is a little bit older technology than before GSM. Now CDMA, GSM is Global System for Mobile Communication, and CDMA is Code Division Multiple Access. Most of the times they stop at 2G, maximum 3G. These are 2 methods of cell communication that survived the earlier generations. They still support 2G and 3G phones. One of the biggest difference between these two is the GSM phones use SIM cards to link a particular phone to this network, whereas CDMA phones do not require a SIM card because the phone itself is linked to the network using a number. Most CUG line, CUG is closed unit, closed user group. A lot of closed user group devices, for some companies, they use the CDMA technology. Now, you see on some phones, you're going to see preferred, especially for roaming. When you are looking for a network, you can check your phones, look at where, especially when you are off your location where you have service. Some phones, some ISP gives you option to you for you to be able to roam. Roam means that you want to use another provider as a gateway into your own network.
Yeah.
Right? So some providers are going to have some preferred roaming list. So they might tell you to dial a number so that you can port and use the network of where you are to actually connect to their own network. Of course, you pay higher and they reconcile the fee with those providers. Bluetooth is kind of an older technology, but I don't know if phones, yes, most phones still have Bluetooth. Laptops still have Bluetooth. It's still a means to transfer short files, small files, files that are not too large, but files that are quite a little bit larger. You want to use USB drives and the rest. Not too large, short range, Wi-Fi, very small, not so much, then Bluetooth, right? So in terms of generation, you are looking at infrared versus Bluetooth versus Wi-Fi versus what again? Drives, right? So the what's it called? The in terms of generation, so we had infrared first, then we now have Bluetooth, then we now had Wi-Fi, then before we now had drives. Bluetooth, infrared, and Wi-Fi are all different types of technologies used for data transmission. Right here, we're talking about transmission. Generation will also tell us at what speed can we transmit. Right, so Bluetooth is going to be slower. Sorry, infrared is going to be slower, followed by Bluetooth, then Wi-Fi. With Wi-Fi, then with drives or fastest USB cable. There's what it's called. Don't forget, for USB, you have 1.0, 2, 3, and you also have 4. 4 is the fastest, but there's a cable. There's what it's called. If I remember, I'll let you know. It's in older PCs, and it's always used for videos, for transferring large files, because videos are always very, very, very heavy. So you see, this is somebody trying to explain the both of them. You have infrared, then Bluetooth, then Wi-Fi, then of course we now have cables. And at times, depending on the deployment, Wi-Fi can be very, very, very fast, depending on the MB per second. You can have so much speed that you can transfer maybe a terabyte within just a short space of time. Whereas if you're going to be doing infrared, it's just going to be something that's very, very close to you, almost at close range. Then, of course, Bluetooth, a little small distance. Then for Wi-Fi can go some great length with a higher frequency. So you want to be able to understand the different technologies and be able to differentiate them.
Yeah. At least this Wi-Fi, Bluetooth, and the rest, one has a first-hand idea of them already.
Good, awesome. So normally, if you want to transfer stuff from your phone to your laptop or from your phone to phone, you have to do pairing. So pairing, the two items have to do some kind of synchronization. Then before the transfer starts, you have to scan. Once you've seen it, then you add it, then you pair, then before you cannot transfer. So go to settings, connection, enable the Bluetooth. The Bluetooth has to be enabled. If it's not enabled, then you cannot do transfer. Then, of course, you start scanning. Once you see You pair. Once you pair, you enter the PIN code. Some of them have a way of pairing without the PIN code. Then, of course, you can now start transferring files. This is an example of you having a headset and you trying to use it to connect or play music. So GPS is global positioning system. It tells you at what point in time, at what point you are on the planet. So it can be used for tracking. It can be used it can be used for even to know what ISP mast you can connect to. And it's used for several purposes. You can use it for tracking, you can use it for mobility. So it's something that is very handy when it comes to mobile. So you can talk about mobile without talking about GPS, right? So when people are connected to mobile devices, they manage to keep moving while staying connected to their network providers. As they move the location between Wi-Fi and cell towers, their phone can be tracked by using the phone's GPS. So with that, the mask can actually know where you are and which to prioritize and connect you to. So it's also useful if you are in cybersecurity. Now you start learning things like getting people's location, getting people's IP, creating a Python script to be able to track somebody's GPS and all of that. So these are very foundational knowledge that is going to help you later on. Now, mobile device management. This is very, very key. Now, later on, when you start doing cybersecurity or you're going to do cloud computing, you're going to find out that this is very, very key. Why? If a company has 50 mobile devices deployed to different locations, how are we sure? How do we know where each of our staff are? How do we know where they are? How do we know what they are doing? How do we know what software is installed? How do we know their routines? How do we know what kind of data they are collecting? So there are different types of MDM softwares. So Cisco has, Google has, different providers have. All they do is to help you secure, monitor, manage, support multiple different mobile devices across the enterprise. So companies are going to use that to actually manage their staff. Manage, if you deploy 50 staff to the field to go and collect data, maybe to do HIV tests or to do hepatitis or to do interventionist program or to collect data for a sort of survey, or you deploy them to sites where they do some jobs for you. How do you know where they are? How do you track their location? How do you be able to collect the data they are providing into maybe your central database? That's why you have MDA. So MDM has to do with what? Mobile device management. Yeah, so if you say MDM top 5 softwares, you're going to see quite a lot of them, right? Quite a lot of them. So you have several providers. You have MAS, you have Manage Engine, Microsoft Intune, you have Hexnode, Jump Cloud, Mobile Device Manager, AirWatch. AirWatch, very, very common. Then you have Endpoint Central. So this is just for us to be able to have a central place to manage most of our devices. I think this is by Google. Let me see. Okay. So you have mobile application management. So just to, as organization needs to manage their mobile device with MDM, it's essentially to manage the applications on those devices. You see a staff, when it comes to security now, how does it apply? A staff, you believe that something is fishy about a staff. So even the staff runs away, you can easily wipe out everything on that mobile device. Phone. Yes. You can even render it useless. You can lock it. You can wipe out all of the software. You can back up of the software and retrieve everything. And now before you issue termination letter or something. So you see some MDM are going to also have MAM. So this is just for better selling points.
Okay.
So the purpose of MAM is to allow companies to control the software and data used on its devices, no matter where the user is located. How it works is that you can be using, let's say, Google or Microsoft, or you are using OX Exchange, or you're using a custom email provider, each of those devices are going to have an email. So the management is always tied to the email. Just like you cannot use an iPhone without an Apple ID.
An account, yeah.
That's how you cannot use an Android phone without a
Google ID.
Google ID.
Google email.
That's how you cannot use new Windows laptops now without a Microsoft ID. That's how it's going to be that you can install the software on those mobile and you tie it to that email. So you can typically do anything with that mobile, even when that mobile is not with you.
That's
so
nice.
Examples of secure practices that companies and organizations can enforce with MDM and MDM are what? Corporate email communication configurations. Now you ask the question, okay, you have social challenge, you have this challenge, you have this challenge. How do you solve it? How do you ensure that it stops this, that? What is going to be your answer is going to be MDM or MAM, right? If it has to do with the softwares and the data, it's going to be MAM. If it has to do with actually overall management, it has to do with what? MDM.
Yeah.
So best practice is make sure you have 2FA and make sure that you're able to manage your corporate applications. Then mobile synchronization. Yes, it's possible. Some of these softwares gives you opportunity to be able to sync data. Right? If you sync data, then you're able to have those backup from time to time. Google Drive can do that for you and other tools. So what is synchronization? Synchronization is the matching of files, email, and other types of data between two computers. The type of data we synchronize are too numerous to list in one chapter. So examples are contacts, email, calendars, right? Why do you need to list? Why do you need to sync calendar? On your Gmail, if you have an event, you can tie it to your calendar. You can tie it to the list.
Gives you a reminder.
Yes, you can put a reminder. You can have 5 persons within the company. You share it, the calendar. Once they accept it, tie it to their calendar, then everybody gets notified. Oh, your meeting is in 20 minutes time. Your meeting is in 5 minutes time. So it's all good that you have most of these things all backed up or synced. So where can you sync to? To the cloud, to 365 Active Sync, calendar, contacts, or your commercial mail application. There are some providers that can help you do this. I've mentioned them. You have Google, OneDrive, Apple, Microsoft, and also Dropbox. So they can provide space for you so that you can actually sync this stuff and back up your data, your calendar, and everything. So that whatever happens, you can always be rest assured that you have your data. Same thing happens for email. Email will have to do with the exchange or the Google or the provider. They all have their synchronization environments. That's why if you're always syncing your contacts with your Gmail on your phone, it then means that if you get a new phone,
you can just drop.
Yes, like in one of my phones, I have my contact in my main phone and I have that particular email on the other phone. So that if I'm not with one phone, I can easily still track and read my mail. So that's an advantage of syncing. So you can sync your email, sync as many things as you want to sync.
Even your contacts, you can have the same
contacts.
contact on different phones once you put the same email on
so that you're not asking who is calling me and the rest.
Exactly.
Okay. Objectives. So complete the tables and list from memory. Key items, right? Keyboard, pointing device, hard disk drive, solid state drive, wireless, near field communication, liquid crystal display, implant switching, twisted pneumatic, vertical alignment, organic LED, mini USB, lightning, hotspot, Bluetooth. So these are some of the items that we've considered in previously. So which of the following is best for built-in RAM in most laptops? There's nothing like DDR-SD4. There's nothing like SDR-SD-RAM.
Then C will be the answer there.
You have You don't have anything like dim, so dim. You have DDR4.
Yes.
You have anything like DDR SD4. So this is a distraction. This is a distraction. When
or DDR3.
When we say dim actually is the type of RAM. So I think your answer should be SODIMM. So SODIMM is a type of RAM. So DIMM versus SODIMM. So one will be for desktop, one is going to be for RAM. DIMM versus SODIMM. So SODIMM, small outline dual inline memory, smaller outline and thickness than standard DIMM, primarily for notebook computers. So DIMM is a memory module designed for network servers of high end workstations. Can I use, do laptops use DIMM or SODIMM? So if it is DIMM is for desktop, SODIMM is for laptop, yes. So correct. So desktop, laptop. So the answer is C. Which of the following is the term for a smartphone that shares its cellular data connection with a laptop via USB cable?
Which of the following is the term for a smartphone that shares its cellular data connecting? Tethering.
Yes, good, tethering. So this has to do with Bluetooth. This is USB. This is a means of getting data. Then this is for wireless. So USB is what? Tethering. You have been asked to upgrade an aging laptop without replacing it. Which option do you add to provide the fastest possible update? Upgrade an aging laptop without replacing it. Which option do you add to provide the fastest upgrade possible? So this is off it, hard disks,
SSD.
SSHD. So our answer is SSD. So that's the simplest. This is RAM, this is hard disks, but this is a newer hard disk. Okay, you have some questions. You can always try out yourself. Towards next week, we'll start looking at questions comprehensively. Let's see if we can be done with the core content. Okay, so you have another session here that has to do with networking.
Okay.
So you have some pre-questions. Okay, let's answer some of the pre-questions. The goal of self-assessment is to gauge your mastery of the topics in this chapter. If you do not know the answer to the question or are only partially sure of the answer, you should mark that question as wrong for the purpose of self-assessment. Giving yourself credit for an answer you correctly get skews your self-assessment results and might provide you with a false sense of security. Okay, so we want to get into some networking. Let us gauge our idea about what we're about to learn. Which of the following application tags would likely require TCP? So TCP is Transport Connection Protocol. Which of the following application tags require TCP? So TCP has to do with connection-based connection. You know, we say TCP is connection-based connection, and UDP is connectionless based connection. I think that I explained these items when I was doing the intro for the modules, or I was going through the A+ objectives. Okay. A DHCP request on a network, send an Excel spreadsheet to a coworker, a web-based phone conversation, streaming a sport event on the web. Streaming is UDP, UDP. This can be UDP. Then this is going to be, what was it called? TCP. Because this is going to be a three-way handshake. This is dynamic host configuration request on a network. So a laptop or a desktop or a phone is trying to request for IP. So you need to understand how DHCP works. So DHCP is dynamic host configuration protocol. So that works together with ARP. ARP is address resolution protocol. So for a phone or for a device to have access to network, it has to first make some requests. So there's going to be some kind of three-way handshake, right? Before it's now assigned an IP address. Which statements about UDP are true? Choose two. So UDP is user data profile, wrong. UDP is data protocol correct. Connectionless correct. Connection rated no, that's TCP. This is wrong. So the answer is this and this.
Okay.
So don't forget, in the last learnings, we also did a full table that differentiates TCP and UDP. True or false?
True.
We also listed the protocols and their port number. So this is what is this session is now testing your ability to understand networking terms, understand what is what. So which protocol uses TCP but not UDP? IMAP, this is going to be email. UDP, HTTPS, this is going to be TCP. This FTP, this is this can be UDP. Then DNS, this is UDP. So TCP but not UDP is going to be HTTPS. Okay, which protocol requires less processing by networking equipment? So of course, it's UDP. This is heavy because it has to guarantee connection before you start even transferring data. I mentioned that when I was doing my overview of the modules. So you go back and watch them because I did a lot of explanation, even in just the what's it called, explanation. I think maybe I didn't record that first section when I was just overviewing the curriculum.
Yeah. UDP is connectionless.
Yes, UDP is connectionless.
That's B.
No, which protocol requires less connection by? Yes. The answer is UDP because it's connectionless. But for FTP, can you try? It's 21.
Which port is used for FTP?
Okay.
27.
That will be all. So we'll move to the module properties. Foundation topics, TCP, UDP, protocols, and their purpose. I think we've done that. So we're just going to recap.
We've done that, yeah. It's just for me to read it up again. I remember you did all that one.
Yeah, so TCP, UDP, the port numbers, the differences, the advantage, the disadvantage, the protocols, and the purposes. So you want to put that maybe in ChatGPT, OpenAI, and get it in a table format and study for your exam.
Yeah, I'll do that on myself. I'll read through this TCP. Let's move on.
Okay, good. So let's do a 10 minutes break. I will return and we'll continue from here. We'll define protocols. I think I did that also in that first stuff. We'll define protocols. Protocol is just like a line of communication. Then we'll look at most of this networking stuff.
Okay.
So let us look at TCP and UDP ports, protocols, and their purposes. So this is in Objective 2.1. Compare and contrast TCP and UDP ports. So when humans want to share ideas with each other, they agree to use communication protocols or rules to make sure that they understood. Protocols help us know when to speak, when to listen, and how to finish the conversation, and when to start and finish conversation. We constantly use protocols, but rarely think about them. When people have a communication failure, protocol failure is likely involved. Protocol serves the same purpose in computer networks, right? Because the processes involved in computer communication can be complex. So the idea is that we have several things and we want to do. We have several ways we want to communicate. We have several types of communications that we have. So the question is, how do we make sure that we have all of those things sorted out? How do we make the lines of communications different for different purposes? So you have different protocols, you have their port numbers, and you have, of course, ways they can be applied, right? You have different ways they can be applied. So both UDP and TCP use ports to make connections. So what you should know, understand, like we did in that previous class, is the protocols, the port numbers, and their application. Okay, you have it here, right? We did this thing in the first introductory class. So 2021, so is FTP. Then you have 22 is secure shell. Telnet is 23. 24 is SMTP. 53 is DNS. 67 is DHCP. 80 is HTTP. 110 is POP for email. 137 and 139 is network basic input output system, and so on and so forth. You could just go on ChatGPT and say top 20 common ports, protocols, port type, and application or case study. Get me my answer in a tabular format. So you should revise that and be very familiar with it. Okay, FTP is a file transfer protocol. I have a file transfer protocol, FileZilla. So I use it for transferring files to my hosting platform. You could use it to send files. I think even when you do Cisco, you can also use it. For instance, this is going to be the host. Let's say soutechventures.com. Maybe the username, the password. The port is going to be by default 21. Are you seeing it?
Yes.
The default for FTP is 21. The default for SFTP is 22. Can you read that?
Yes.
Okay, good. So this is where your files are. This is your server. Once you make the connection, this is going to load, so you can transfer your files, and you can just drag it and drop it here, and it's going to show up.
All right.
You can see when what has been transferred, what is queued, and what failed. You can right click and reconnect it, and it's going to keep moving. If you want to do backup, also the same thing. You can use to transfer files from your server to your own system. Once you connect, your server end is going to load there. You can create a folder on your system. So this is like your system. This is like your, you can move this. This is like your desktop. Once you say your desktop is going to load, so this is your desktop. You could create a folder here, create new directory, backup. This is it. So you can copy the files here into this place.
Okay.
If I go to my desktop, I'm going to see that backup I just did now, right? You can also move things from here into this place. Once this is loaded, you can also create a folder, you can create a file, you can download the file, you can do whatever. So this is what you call a file FTP software. There are so many top FTP softwares. So you have FTP softwares, you have TFTP softwares. So TFTP is Trivial File Transfer Protocol, right? Trivial File Transfer Protocol. As you can see, the one I use, FileZilla, that is this one. Then CyberDog, Fire FTP, Smart FTP. I think in the past I've used 1, 2, and 3.
Okay.
Over the last 15 years, developing websites or applications or trying to push stuff to the cloud and the rest. So I've used this, and I think this. So, but the one I love so much, it's this FileZilla. Okay, so SSH is secure shell. So if you need to do some exchange, and the thing about FTP is it is a plain text protocol. So why do you call it a plain text protocol? When we start doing security plus, for those of us that are interested in doing security, doing cloud computing, why you're learning most of these things in CompTIA A is to lay foundation for such. Because in cybersecurity, our interest is, yes, we understand these port numbers, but which should we use, and at what time should we use them? Because for each of them, you have some vulnerabilities associated with them. For instance, if you're running a tool like Wireshark or some sniffing tools, you're able to capture this username and password that the person is using here if you're on the same network, which is a big blow.
Okay. Yeah.
So you don't want to use that. You want to use SFTP. SFTP is going to be 22. If the site has security implemented and you use SFTP, it then means that that software, if you're trying to scan this network, Whatever you're going to be seeing is not going to be in plain text. It's going to be in what we call ciphertext. So ciphertext is the scrambled version or the encrypted version of the plain text. So when you start learning, so when you start learning cybersecurity, these things will not be applied, because you're no longer learning about port numbers, all of these. You're learning how do you ensure a secure communication.
Yeah.
Good. So this is called SSH. You also have the option of SFTP. Telnet. So Telnet is text-based connection on remote computing. Most systems have Telnet disabled for security reasons, so that people cannot, like Telnet, people cannot like connect to the system and maybe collect files or download files or whatever. So Telnet, you should know each of them. Like I said, in your table that you're going to be getting ready for exam or to understand this concept, just test ChatGPT to list the top 20 protocols, their port numbers, their usage applications, advantages and disadvantages, and case studies. Put the answer in a tabular format. You're going to get something very awesome that you can use for your revision. So you have Telnet, you have SMTP, it's for mail, right? SMTP is for mail. Anytime you hear the word SMTP, it's, you know, it's simple mail transfer protocol, and it's port 25. Anytime you hear the word DNS, that's what controls our domain name systems, hosting servers. I think I showed you in the last class when you said, when I said you say who is, and you're going to say, yes, southtechventures.com is going to tell you southtechventures.com registrar is Namecheap. It was bought in 2010. It's expiring 2013. That's 13 years down the line. The domain name server is jessica.ns Cloudflare. So this uses a CDN, content delivery network. If I put Southtech hosting, another of our sites, we're going to see Southtech registered in 2015. The name server is what? NS1 southtechhosting.com, NS2 southtechhosting.com. So this is the name server. NS is what? Name server. If I put another site, let's say southtechapps.com, I'm going to see, okay, Southtech Apps is on Namecheap. It's registered in 2018. You see it, NS1 southtechhosting.com, NS2 southtechhosting.com.
Acting up again.
Come again. So if I say southtechserver.com.ng, I'm going to see, okay, registered in 2018. Name server is ns1 southtechhosting.com, ns2 southtechhosting.com. So this tells you the word, the name server. This is going to be what? Port 53. Always bear that in mind.
Okay.
DHCP. So one thing you need to know about DHCP is it tells you how IP addresses are going to be assigned to host. I already explained that earlier on. So it uses two ways to do that. The ARP and the DHCP server. So every router has DHCP server, right?
Yeah.
So any system that's going to connect to a router or connect to something or pick up IP address, the two ways it's going to get IP address is going to be either DHCP or it's going to use a static means to collect IP address. Then, of course, you have HTTP, HTTPS. This is the non-secured. This is the secured. This one is 80. This is 443. Most browsers connecting with a secured site will display a closed padlock symbol on screen. So this is it. If you tap it, it will tell you it's secured. If you tap it, it will tell you it's secured. And look at this one I'm just building. I just started setting up this site today. If you tap it, it will tell you not secured. So by tomorrow, I should have implemented security on this site. This will now turn towards secured.
Yeah.
So POP is also for email. NetBIOS, it's the configuration that tells, especially for legacy applications, you don't see it of recent. Again, IMAP is for email also. Then POP is also for email. IMAP and POP, they are for emails. If you configure Outlook configuration, you're going to see two options. You're going to see IMAP or what? POP.
POP.
So what you do is that you check from the hosting service, extract the configuration for Outlook, and you can now configure your email to either POP or IMAP. So you have SNMP. SNMP is Simple Network Management Protocol. What does this do? This tells about how all the devices are going to work together. This is like the management system, right? So manages routers, switches, computers, often incorporated into software known as network management system. And this is always on your router, inbuilt, right? Then you have LDAP. So LDAP works with Microsoft systems, right, for directory services. I think you are doing a course on is it device management or remote something Microsoft. So you're going to see more of this in that curriculum. Then you also have SMB, server message block. This has to do with authentication, right?
Yeah.
Provide access to shared items, right? Access authentication. So remember in the previous training, I talked about 3 ways you can do authentication. It can even be 4 more. What you have, what you know, what you are, where you are. Those are the 4 regular ways you can do authentication. So, and the server message block has to do with authenticating. SMB uses packets that authenticate remote computers through inter-process communication mechanisms, right? So it uses between port 137 to 139. So this is in your Windows system, right?
Yeah.
So Microsoft uses this. Then you have RDP. So anytime you hear the word remote desktop computing, you have a course on remote desktop computing. So you know it's RDP. The port is what? 3389. When we're learning operating systems, we'll discuss that in detail. Then you should be able to differentiate between TCP and UDP. Understand that TCP is connection-based protocol where you have 3-way handshake. Then UDP is connectionless based protocol where 3-way handshake is not necessary. TCP versus UDP. So are you seeing? For TCP, hello, I want to speak with you. Okay, what is your issue? Okay, I'll get all the details to you now. Communication start. Here is what I need.
Direct.
Orange. Take. You can say, I need orange. This guy is not available, and communication ends. But before this guy can start sending oranges, hello, please, I am sender. I want to speak with you. Okay, what's your issues? Please be fast. I don't have time. Okay, don't worry. I'll go to send them now. I need orange.
Yeah.
So this is TCP. So this is connection based. Connection has to be established first before there's communication. Here, connection don't have to be established. So you have application here in voice over IP. You have application in streaming. You have application in remote video gaming and all of that. You have application where you have where guarantee of communication doesn't have to be much of a concern. You have application where the data that needs to be transmitted is quite large. Then this is often used in web applications and all of that. So you're able to know the differences and know their applications. This another differentiation here. You have connection. This is connection rated, not connection rated. Usage, high reliability, when we need to guarantee transmission. Where we just want fast and we have huge numbers, right? Of clients. Things like streaming, YouTube streaming, video streaming, online gaming is going to be UDP. Voice over IP telephony over IP. Ordering of packet, this is always very rearranged, very, very ordered, no real order. So you can have buffering here, right? Error checking and recovering is always done. Then error checking can be done, but you don't have recovery. There's acknowledgement of each segment here. Segments are not always acknowledged. So reliable, yes. Not reliable, no. Now, when you talk about advantage and disadvantages, it's not that this is better than this. This has its own application. It's done for a purpose. Imagine when you need to send large sum or large streams of data. UDP is your best bet. You cannot do that on TCP, right?
Yeah.
So they just have their different applications. Okay, now networking hardware. So this is where we should be able to differentiate between router, switch. So normally in networking, if you check the channel, you have, it will also help you to check the playlist on, networking. On the playlist on networking, you have
okay, good morning.
Let me see if I can get something.
Okay, good morning, good afternoon, or good evening. My name is Victor, and I'm going to be going to use modulation between different frequencies. That's why if you try to configure some router to your system.
Okay, so this is the summary of networking. So networking is actually end devices, intermediary devices, and network media.
Yeah.
Right? So when we talk about devices, when we talk about components of my network is divided into, what am I going to be serving? Who is going to be serving them? Then how do I serve them?
Yeah.
So you can be using Bluetooth, wireless, LAN cable, WAN cable, fiber optics, coaxial, whatever you can use to connect them is called your network media. How you're going to serve them is going to be, what you're going to use to serve them is going to be your devices, right? Your router, your firewall, your LAN switch, your multi-layer switch, your wireless router. Who are you going to be serving? Is going to be the desktop computers, your laptops, your printers, your telepresence endpoints, your wireless tablets, your IP phones, and all of that. So we're talking about networking hardware. So it covers everything that has to do with the different devices that's going to help us build our network. At times we refer to as small networks as SOHO. So SOHO stands for Small Office Home Network, right? Small Office Home Network. So with A+, you're able to set up a small network. And for you to set up a small network, you need a router, you need a switch, and maybe you need your devices. So understanding how computer communicates on a network is essential for an IT professional. Network environments can range from simple home networks to complex corporate designs, but certain essential elements and functions applies to all network. So a router, explain what a router is. A router will help you connect between one network to the other. It seems my network went off.
Yeah.
Okay, so I'm going to write on. So you have
I can't see your screen again.
Okay, just a moment. Can you see my screen now?
Yeah.
Okay, good. So you have the cables for your Ethernet ports. Then you have the main source of internet. Now, the way this router is built to be able to also extend internet. Now you have different types of routers depending on its role. Some of them are provided by ISPs. Some of them are basic routers that you could get a wire, send into this guy. That's why you see this Ethernet stuff. Right? So what happens is that they can send Wi-Fi signals. It will have internet. Then any Ethernet port plugged, any case system plugged here is going to also get internet. You also have some of them that they don't have this source Ethernet access, but they have a route, a SIM inside, and they are supplied by a network provider.
Okay.
Routers are specialized computer devices that are controlled by firmware. So that firmware is just typically the software that runs the hardware. Like the one I showed you, my network is 192.168.1.1. So this is like what runs the entire network, right? What runs the entire, this is owned by this ISP provider. Okay. Any other thing of importance? Then you should be able to differentiate between a router and a switch for your exam. And you should also know your OSI model, your open system interconnect, OSI model, and devices. Right? You should be able to tell what device you have at what layer. Very important for your exam. You should understand that router is a layer 3 device and that this looks small. Can you see?
Yeah.
Is it clear enough?
Yeah, it is.
Let me get something else. Still the same thing. Awesome. It's clear enough?
Very.
Good. Physical layer, what's the function? Sends data to the physical wire. Data link layer, what does it do? Read MAC address from the data packet. Network layer, what does it do? Read IP address from the packets. Layer 4, what does it do? Protocols. Layer 5, what does it do? Establish end connection between two hosts. Layer 6, what does it do? Encrypt. How do I present? How do I send my data? Application, services that are used with end user application. What are the protocols? What are the devices? So switch is a layer 2 device. Router are what? Layer 3 device. When you say layer 3 switches, what you mean is that you have switches which originally should be layer 2 devices, but they can perform layer 3 functions. That means they could give people IP addresses and our devices IP address, and they can also connect it to another network. So you call those type of switches layer 3 switches.
Okay.
If you have a question that has to do with layer 3 devices and you see layer 3 switches, yes, it's correct. Don't get confused. Yes. You're surprised. Yes, so
because it might be confused, even saying it even sounds confusing.
Yes, layer 3 switches. So layer 3 switch functions both as a switch and a router. These devices are perfect solutions for VLANs as they do not have WAN interfaces that performs routing functions in addition to switching, like I said. So all these devices are switches, but they're layer 3 switches.
So you said layer 3 switches and layer 3 switch. There was the way you just said it now that they are not the same thing.
Come again.
You just made a statement which I said sounded like similar, but you said
Yes,
it's not the same.
I said you have layer 2.
Okay.
I said you have layer 2 switches and you have layer 3 switches. Switches are generally, if you are asked, you should say switches are layer 2. But you can also add to say that, okay, we still have some layer 3 switches. What's the function of a switch? A switch what? Forward packets, right? That's the job.
Yeah.
Just push what Mr. A wants to Mr. B. Push what Mr. B wants to Mr. C. You just have a switch and pieces.
Yeah. It's in that video. I just saw it.
Good. You just have a switch and PC1, PC2. So just this guy says take, you take. This guy says take, you take. That's all. That's the function of a switch. It's just like a junction box that will help you send people forward packets. Now, once you add if you have a WAN network, what's going to happen now is that this is LAN. You can have a server, or this can be a switch. This is a LAN. You can have a what's it called, switch thereabout. Then if you have, okay, let me look for something that will help me explain this. Just a moment. Okay, let me just say router with switch, LAN, and pieces. Let me see. Good. This is an example. You see a router, that's the guy that's going to connect Mr. A and Mr. B. This is a network. This is a network.
Yeah.
There's another network that can also be the internet, which is the network of all networks. So it's only this switch that can connect us. And this can be owned by the ISP, or this can be vendor neutral. So if we want to connect all of these guys to the internet now, it is just a regular router. We'll get, let's say, Verizon, we'll get Airtel, Bati, MTN, whatever. We drop it here, connect it to this guy. Then all the information here can go like this and go to the internet, to our friend in Tokyo. Without this router, we cannot leave this place. Without this router, these guys cannot connect to these guys. So this is a network. This is a network. That's why you define a switch as a device that helps you forward packets. Where is it forwarding the packet to? Amongst itself. What of the router? It can forward from this LAN network to the other.
Yeah.
That's the differentiating factor between a router and a switch. And you should also know that switch is layer 2, whereas router is layer 3, but you also have layer 3 switches that perform layer 3 functions. There's a switch. Then you now have wireless access points. So if I want to do some extensions, I might need a WAP. So it will just extend a wired network to wireless connection, right? I'm in block A, I have a router, I have some switches, I have some PCs, but over the fence, over the next building, I need to also have connection there. So I can put a cable here, send it down, and that wireless access point, which is also like a router, cannot extend what I have here to those guys in a wireless format. So they cannot connect to it wirelessly. So you see that in banks, you see that in hotels, you see that in offices. So it turns a wireless router into a WAP, right? So you need to connect it to a separate router. Patch panel. So I think you don't have an image here. So just to help me send in my cables, right, and sort them out properly. You have them in different it can be 1, it can be 2, it can be 3, it can be 4, but once it goes above a certain number, you start calling it a panel, because this can be on the wall, this can be at a rack, this can be whatever. They also have your Ethernet sockets, right? You have something like this also.
Yeah.
So This is going to be into the wall, so this is going to come in. So you just plug at your short distance, your laptop and here, or your desktop and this place. So this is called an Ethernet socket, right? Then you have your patch panel. The patch panel is going to be the guy that is going to help you extend all of this stuff at this point so that you can now connect directly one after the other. So what a firewall does is that it helps us to protect from unwanted intrusion. When you start learning about cybersecurity, that's when you start talking about IDS, IPS, HIDS, NIDS. So for now, it's sufficient to understand that even your Windows have firewalls, right? And it's to protect your system from intrusion externally. So that if somebody is trying to like pilfer or trying to do rats,
hack you
or remote access Trojan or whatever, your system can be protected. Then there's this concept about power over internet, PoE. Okay, let's examine the Cat6 cable wires and functions. Okay, let's examine the Cat6 cable, either 5, 6, 7, 8. So because we want to understand power over internet. When you say power over internet, what are you trying to achieve? Now, normally, if you need to connect any device, like just like I explained for USB cable wiring, I explained that USB cable has this as power, 5 volts. So USB always going to give you 5 volts. Any appliance, router, or camera, or whatever that needs 5 volts, your USB can charge it, right?
Yes.
Now, the data is this and this, then this is just your ground. So even if your ground is bad, you can still have power, you can still charge your phone. Now, for your Ethernet cable, what's happening is that these two guys are used for what? For power, depending. Now, most devices are going to, like this kind of device that are outdoor devices. You're going to, yes, you're going to see that the way you can connect to them is going to be through an Ethernet port, outdoor devices, or an IP camera. Right? You see this IP camera? This is for power. This is an option for data if you are doing any form of conversion. But for a regular IP camera, if you just plug this cable, this Ethernet cable, you can power this guy and you can pick up data. It then means that that cable, that Cat6 cable, is taking power and data together. Ordinarily, for an analog camera, you are going to need 2 things. You are going to need power and data. That is power and video. Power and video. That's what you need. So you need to send 2 cables. So if you have something like this, let's say in your building, don't forget that this cable is going to go from somewhere within the office upstairs and like that. The idea is that we want to send only 1 cable, only our Cat6 cable. But when we plug it, we need to put it into a PoE adapter. right? So that cable, one goes to the router or go to the device. It enters here. Then this now goes to the LAN. What happens is that when I plug this adapter on my socket, it's going to be feeding power to that cable. I don't know if you understand me. It's a very practical item. If you do CCTV connections or you do networking, there are some devices that are going to need you to have there are times that you need to send cable to a long distance, or so the only best way to do it is to use a PoE device, or you see some device they'll call them PoE, or let me also use PoE switch to explain to you. This is a PoE switch. What this means is that this switch, the way it is, you can, if you plug this switch on power, if you put a cable here, that device is going to get both data and power together. That's what it means. So you're actually sending power over Ethernet. That Ethernet cable, you're not just sending and collecting data, power is also going. So that device does not need a power adapter, right? So that's the concept of PoE. So its application is in access points, IP cameras, VIIP phones, routers, and other Ethernet devices, to be installed in areas away from traditional power sources, right? Like I told you, in a roof point, somewhere very, very far, there's no way you can do it aside, what is it called? Using a PoE switch or a PoE adapter. Okay, so they have different power sizes and ratings. 12, then you have maximum is 15.4. We also have PoE++ that can also power devices of up to 100 watts. So a hub is typically not used these days. It's a little bit older. So it's the simplest form of device that will just help two devices to connect. Its disadvantage is that it's just like a box that cannot control traffic. So a switch is going to control the traffic, the packets of data moving between points, and it's a better use case for managing devices. So hubs are older. Back then, if you use a hub, it then means that almost every 1 hour or 2 hours, because of a lot of communication back and forth, you see the systems or the pieces will now lose communication. So you just have to restart it. Once you restart, you cannot, everything now starts working. So those have been replaced by switches, right? Then you have modems. So you have cable and DSL. This is also older. It's an older technology. People don't use modems again. Dial-ups, most of them are analog. People now use routers to connect to ISPs. They have also optical network terminal, fiber. This is for fiber. Then you have NIC. This is like your interface. When you say NIC card, it means that adapter, that thing that is helping you to connect, and that is what is going to be the MAC address, right?
Yeah.
So every device have an NIC. It can be wireless, it can be LAN. Or rather, it can be wireless, it can be Ethernet. Software-defined networking. What does this mean? We're trying to say that we no longer want to manage our devices by just hardwares or by running codes or doing chaka 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 and hit enter. No, we want to go beyond that. Okay. We now want to use software to manage the device. Take, for instance, if I say 192, this is the software that's actually managing this router. Can I remember my password? I doubt. Okay, let me see. A second. Okay. Can you see my screen?
Yeah.
I couldn't get my password, so what can happen here is that I can see this, I can see the items connected to this router, so I can log them off. I can decide I don't want people accessing this router to be able to browse Facebook, Twitter, Instagram, YouTube. What is actually happening? I'm defining my network using this software. Right? I'm not coding anything. I'm not networking anything. I'm not running some script. I'm not necessarily script. I'm not running some kind of configurations.
Yeah.
I'm just using this software to define the entire network. Have you
To
seen?
manage the settings.
Yes, a software is used to shut down the system. Yes. You see, with this router, if you go to the settings, you can reboot this device. And whatever the device is going to restart. So you see, I am managing that network using what? Software.
SDN.
Computer networks are made up of devices that are connected together. Over time, the technical abilities or capabilities of the networking device have grown in scope. It's no longer practical to have human interaction to manage every device and configuration for large networks. So what do? We can virtually create softwares that can help us do what? To manage it. Either we want to send, we want to receive, we want to process, we want to tell what is possible on the software or router or what is not possible. We want to do things like access control. We want to tell you what you can do with the router and what you cannot do if you're on the router. That is the summary of software-defined networking.
Cool.
So here you're talking about wireless protocols. So we have different frequencies, bands. You can also use ChatGPT to tell you the wireless frequencies, their band, their differences, their advantages. Now, the lower bands are going to be affected by interference, right? And they're going to be lower in speed, whereas the higher band will be able to go far distance and they can pass through walls. That's why you can put a router here in your room and you are in the kitchen or you are outside, you can still receive signals. You can put router in the reception and you are in the end of the office, you can still receive signals. So that's about frequencies. So wireless routers use between 2.4 to 5 gigahertz. And if you have 2-3 routers having same band, you are going to have some clash, right? So within your router configuration, I'm not able to enter here. I would have shown you different bands. You can actually do adjustment so that you don't have such kind of challenge.
Okay.
With the 2.4 longer range, slow performance. So 5 gigahertz, faster performance, channels do not overlap, then shorter range. Note, the latest Wi-Fi generation, Wi-Fi 6E supports not only the 2 and 5, but also the 6 gigahertz frequency. MIMO, the number of antennas supported by the router and the adapters, either built-in or add-on devices. One reason for different performance level in a given band, either this or this, is the multiple input, multiple output devices are available in the following configuration. So you can have one transmit, one receive antenna, or 2 transmit, 2 receive antennas. That's why you're going to have some routers are going to have different types of antennas. Some we don't even have antennas. It's like inbuilt within it. Routers, MIMO antennas. Right? They are not for fancy. Right? Some will have 3, some will have 4, some will have 2, some won't have any. It'll just be a high-end stuff that is going to be within the router, just behind it. Right? See options.
Yeah.
Like when we were examining the one for laptops, you know, laptop, they have the antenna, but you don't see the antenna for a laptop device, but it's just by the screen at the top edge of the screen, the 2 sides. laptop antenna. Right? At these two ends, you're going to see them. Right? Every laptop from the board is going to go and come at this end. Here it's going to be at this end. Are you there? It's going to come from this part and go to this end. Right? So every laptop have an antenna, whether you see it or you don't see it. Okay. This is about regulation. And at times in some countries, in some places, you need to get permission, you need to get license. You cannot put in some radios or put some extenders or put some boosters, right? Because if your signal is poor, you can get some antennas to like boost your signal so that you can have better frequencies. Like I said, I couldn't log into my router. If you log in, you're able to select your channel. If you have one at home, you can check up.
Okay.
So it's something like this. You have to log in there. You see the channel. Is it auto? Is it you see all the different options for you to be able to tweak it. So we said Bluetooth is an older technology, right? It's always short range. Most of the times, the two devices have to be together. So that's where you can transfer data. Here we're looking at how do we transfer data, right? I'm looking at some of these terminologies, right? So Bluetooth are not so much in use. People will prefer to use their cables now and also use their, what's it called? But when it comes to speed, wireless is always the fastest. When you compare infrared, Bluetooth, wireless, and cables. So for your exam, you should be able to understand and differentiate the different Wi-Fi standards. There are 6 of them: 11B, 11A, 11G, 11N, 11AC, 11AX. So this is like the latest. So if you have 2 items where this and this it's given, question is which is going to be the fastest, which is going to give us better performance. So it should be the latest technology. Because in tech, we want to be concerned about the differences between the age, and because the newer one is always going to do better. So this is like a summary. NFC, I've talked about NFC. NFC cards, most of the times applied in payments, right? Most times applied in payments. Most ATM cards are going to have that symbol, right? So this guy is going to have some data written to it. So
I can't hear you.
Can you hear me now? Can you hear me now? Can you hear me now? So I was talking about NFC. So NFC is going to be this guy. Data has always been written on it. So most of the times they are applied in payments, right? You just hover it on the what's it called? On the code, and it's going to like pick up the payments from it. There was a time we wanted to do a project on NFC. At times, what kind of thing you can write on it can just be contact. What you can be writing on it might be payment IDs details. So once you just swipe it, then it picks up the data and you can actually tell. Most ATM cards have that symbol, that feature. That means that if that symbol is there, we can use the card, we can swipe the card or just hover the card around it, NFC card reader. So you also have NFC. So this is like a reader. This is like a device. You can read. It can also be used for access control. If you want to use for access control, that means that you're going to get NFC card. You also have NFC read writers. Most readers can write. This is a device that can read and write. So
Okay.
you buy the empty cards. You can buy the empty cards, buy NFC empty cards. Right? You could buy it. Normally, they'll tell you 20 pieces for a social amount, 1,000 pieces for, it can even be stacks. Something as small as this, stickers, right? Look at. So, but it has a small circuitry in it. So what will happen is that you can pay for an event, and I'm going to give you a sticker. So you can stick it on your wrist. You can stick it on your phone behind it. And once you come to the event, I've written 1, 2, 3, 4, or your ID or your photo and your details and your event ID on them. Each of the persons I'm going to give it to. So when they come for the event, I just swipe it. It will pull out the information from that NFC, and it's going to tell them that, okay, this is A, this is your photo. It will show the photo that I've written to it and the details, and allow you to pass. I can even authenticate it, and some persons that are into access control can authenticate this system to even open the gate. So if you swipe, you can enter.
How do you write the instructions to the card?
So you need an NFC read write, and you need its own software. And most of the times they don't hold so much information. It can just be in kilobytes.
Yeah.
Right? Let me open something for you to see. Normally, when you are purchasing them, they're going to tell you how much data it can hold, and whether it is one-time use or whether you can use and like read write, or whether as in rewritable. They will tell you, okay, 50 pieces without stickers. This is the size. This is the width. It didn't tell me the MB. Okay, I see it's 504 bytes.
Yeah.
So the kind of information you are putting here, just ID, details, or just a small picture, minified version of a picture. So you need a writer. So with a writer and its own software, you can write, you just place it on top of it. It's going to write that data on it. So once that data is on it, then if it's event or for something, then it just reads the data and maybe they can allow you access. So that's some of the application of NFC. Most of the times it's applied for payment and for authentication. So it's called contactless transaction or contactless authentication system, where I don't need to tap, I just need to hover. Once I hover, it will pick out the information and present what is written in it, and you can be allowed access. So let's look at RFID. RFID is also another, it looks and works like NFC, right? Still a card. So you have RFID card, you have NFC card. So NFC card is more recent and holds more data compared to RFIDs and have more advantages to RFID. So RFID works at distance of hundreds of feet. Communication RFID is typically capable of one-way communication from the tag to the reader. NFC is capable of two-way communication, right? Data storage can store more complex data than simply identifying information, right? It can go up to 4K of data. Of course, RFID is going to contain less information, right? So these are different ways that storage of information can be done.
Contactless cards.
Yes. So this is an application of both technologies. RFID, what do you use them to do? Asset tracking, tool tracking, inventory management, access control. NFC, NFC based on this, but it's an improvement, right? Can use it for access control. So this is called near field communication, and this is called radio frequency identification, right? They are wireless communication technologies. You should be aware of them. When you have questions about solutions that can help us identify documents, that can help us grant access, that can help us identify information, we can put our badge to be able to tell who is who and the rest. We can read data from it. RFID, NFC is going to be your way out.
Okay.
Okay, we have another section in the course. So we're going to go for a 10 minutes break. When we return, we're going to go through service provided by network hosts. So here, what we're trying to say is that the question even is, what is a network? So a network is just two or more devices trying to share resources, right? Two or more devices try to share resources. Resource can be anything. Resource can be file, it can be printers, that can be devices even. It can be it can be printers, it can be a what's it called? It can be a hard disk, it can be a folder somewhere, it can be a software, it can be internet, it can be anything. When you hear the word network, don't think about just providing internet. Think about anything resources, right? Now, what are the different types of services that we can have when we have a network? Domain name service. So that means that people can have domain names tied to IP address.
Okay.
That's why I can say ping this, and I'm going to get something like this. So this is going to give me this. Then if I say NS lookup, I'm going to get the addresses, right? Then coming from my own router, who is giving me answer this range of IP addresses. Now, this what's it called? This website has this IP given by me by the domain name service. If I say this, sorry, if I say NS lookup, let me see. Actually, I'm going to do something slightly different. Okay, not different. So the domain name service that assigns this IP address, because this is like an asset on the hosting service provided by this. So it's the domain name service that can have the domain name translated into IP address. Now, advantage of having a network, we can have domain name service. We can have a DHCP server by a router, so we can assign IP address. We can have a file server, right? Or network attached storage. That means we can have a drive that we can share, other people can use it, right?
Yeah.
File server. Box, right? So we'll have drives inside of it. We can share it on our network, and we can have as much as terabytes and terabytes of data for large enterprise. But for small enterprise, you can just use a network drive, right?
Yeah.
Something like this. Are you there? Western Digital has it, right? And most of them have. Are you there?
Yeah.
Okay, unfortunately, all of them has. I would want to see the back. So this is just 4 terabytes. You can have it in your house, and some of them are Wi-Fi. So that means if you connect to it, you will just see a drive. So this is like a file server. This can be used as a file server. So you have domain name server, you have DHCP server, which is in your router that assigns IP address to you. Then you have your file server. You can use it to like share files across your network, right? Then you have print server that can help you manage your printers. Then you have mail server. That's what your email, where your email is based on. Like you could say southechventures.com/webmail, right? You can say gmail.com. It's going to take you to Google's own mail service. If you come here, it's going to take you to this webmail client, right?
Yeah.
So there are some softwares or some systems that can be integrated by a hosting company just to provide email alone. So you call that kind of thing what? A mail server. What they do is just to do what? Send emails using either IMAP or POP. You have syslog. So this is going to give you some kind of log, system log of what is happening on your network. Somehow, most routers and most servers have this embedded, but for large enterprise, they can have a separate syslog server. And the syslog server can just be a regular server that is being converted to become a syslog server. What it just does is that it gives you log of all of the happenings within your network so that you can track system events, logins, crashes. Just like a regular computer system now have what we call the event viewer or event manager. You can see what is happening on your system over time. So that's the job of a syslog server. So a syslog server is going to serve so many devices on your network. Then you now have what you call web server. So web server is now what you can use to host your application, host your website, right? You have regular service providers. Then you also have cloud service providers. The 3 main cloud service providers are who? AWS by Google, AWS by Amazon, then Azure by Microsoft, then GCP by Google. So GCP is Google Cloud Platform.
Okay.
So there's also called authentication, authorization, accounting. When you do cybersecurity, you're going to understand this in depth. But for now, just understand that security is very key. So for many people to allow people to use any of their both services, whether it's a web server, is a syslog server, or is a mail server, or is a print server, or is a file server, or is a DHCP server, or is a domain name server, I need to be able to authenticate people. I need to be able to like give people access. And the way it happens is that you first authenticate, you allow access, you now authorize to tell them what and what they can do in terms of permissions, then you now account. So we call this non-repudiation at times in cybersecurity. So you authenticate. How do you authenticate? Username or password, your GPS location, your IP address. You can authenticate by your badge or your swipe cards or any of those NFC or RFID we talked about. That's the way you can authenticate somebody to be able to have access to something. The next thing you want to do now, you want to now authorize. Once you come in, the question is, are you coming in as a user? Are you coming in as an admin user? Or are you coming in as a super admin? So
which one is the super admin?
Super admin is like the overall boss.
Okay.
Because you can have an admin that you don't want to have complete total access to everything. A super admin can remove an admin, can create an admin.
Okay.
And at times, if the system is built in such a way, an admin might not be able to create another admin. So, so you have authorization. So by which type of account you use in accessing your authenticated will tell what you can do. if you visit the website now, if you log in as a user, what you're going to see and what you can do has to do with what type of account you have. If you log in as an admin, of course, you're authorized to do some certain kind of other things. True or false?
True.
Then, once you are authorized, they will need to know what did you do while you were there. Can we keep a log? Can we account? Can we ensure that there's no repudiation? So that somebody's not denying that he has had access to something when he actually had access to something? That's where law comes in. So we normally say authenticate, authorize, and account. So this place explains authentication. This place explains authorization, whereas here explains keeping track of resources and activities user has performed while on the network. Okay, I talked about UTM in the last class, in the previous video, the part 1. We'll talk about unified threat management, or we're talking about we trying to have a system, a software that is going to, like, it can be a software, can be a hardware, that's going to help us manage security site-wide. So we don't want to have a different firewall software. We now want to have a VPN software. We now have an antivirus software. We now have an intrusion detection software. We now have a firewall hardware. We want everything to be in one place, right? So you call those kind of software or hardware UTMs. So most of the time they provide firewall, remote access, virtual private network, web traffic filtering, anti-malware, network intrusion prevention in one place. Always very costly, $2,000, $3,000, $4,000, $5,000 above. Instead
for
of
the UTM.
Yes.
Okay.
Top UTM and prices.
And you say it can be hardware or software, right?
Yes, it can be hardware or software. For small to big businesses. FortiGate. It's not putting how much it is. FortiGate price. FortiGate price. Are you there? This for small business. Pay between 1,500 and 4,000 for firewall hardware, right? So they're in that neighborhood. And of course, this is for either per user or group of user, and depending on the number of users you have and the rest. So it's always very expensive, but they tend to put everything in one place. Then a spam gateway can majorly for emails, depending on what you have. In most hosting service, you're going to have it like a spam filter. You can also put, at times, some hosting service will have something that we call like a bot trapper. So if you send email to it, you have to verify before you can allow email to get through, or it's going to scan the email before it delivers it to the person. So if it has, in its intelligence system, if it has gotten that your IP address or your email found wanting somewhere, wherever, they share intelligence, they will just blacklist that email and it's not going to get delivered. That's about spam gateways. Whereas UTMs can be softwares, can be hardware, but we have everything in one place to help us have a better system. Then you have IDS. So IDS will detect, right? IPS will prevent, prevention system. Now, one of the differences is that for IDS, it's going to always be cheaper. They don't prevent, and it might not block the attack, but it will just like give you log. Something has happened. It's not what you configured me to allow. Then look at it here. It will keep that for you. What an IPS is going to do is that it's going to also prevent it. Now, the thing is that an IDS can be software, can be hardware. Both these can also be software, can be hardware. Now, this is going to have an impact in your traffic bandwidth, in your management. So you're not going to be asked very intricate security questions in your A+ exam. These are questions that are meant for S+ or Cyber Ops or EC Council CEH. But you're able to understand the differences between an IDS and IPS, and NIDS, HIDS, and a firewall. These are things reserved for core security exams. But at least you're able to have idea about what an IDS is and what an IPS is. And what is going to be a load balancer? So a load balancer will help us share task and traffic to maximize efficiency. When balancing traffic within a network or handling application processing between servers. So a load balancer increases redundancy. When we hear the word redundancy, think about, I don't want to get useless. I want to get useful. You don't want to have a point where you don't have performance again. So you can put two routers, you can put two systems and use a load balancer to like keep everything and serve your client or serve the PC. If one goes down, you have redundancy in the sense that you can still render service using the second one. So those are some of the case studies of load balancers. Of course, you have a proxy server. It's just an intermediary between a client and another network. Very synonymous to most VPNs people use to access something they're not supposed to access. So what is going to happen is that they are going to connect to another network, and that will now lead them to where they are going to. So proxy server is just an intermediary.
Okay.
Then you have legacy and embedded system. You see, most ATM machines, for instance, so most of the times you say, this is a con. So most of the times you say legacy is actually something older. Then embedded is something that is part of something, right? When you say embedded, you mean something part of something. You can have something in your car that's a mini computer, or you can have something that is part of a larger system. So you see ATMs, you see point of sale systems that are referred to as embedded systems. Of course, legacy systems are systems that are a little bit older. For example, is the MS-DOS application. Some things you need to take note when you look at legacy systems, right, and embedded systems. You want to make sure that you always run updates because most of the times they can get abandoned. And when they're abandoned, they can cause vulnerabilities, right? You want to see if you can also run them in a virtual environment. Once you start doing security, or cloud computing, you start understanding virtualization. So VMware, for instance, is an example of a virtualization software. Same thing with Oracle VirtualBox. So updates and security is always a concern when you use old systems, legacy systems, and embedded systems. IoT, I think I have something on my channel on IoT, so you can look it up. Cisco have a series on IoT. They call it Introduction to IoT, connecting things, and because IoT has to do with, I have devices. How can I manage these devices over the internet? So things here refers to internet. Sorry, things here refers to devices. Like we're trying to do an installation for a client that has a water factory. So he needs to monitor that water factory even when he's not there. He's always on the move. So we're trying to put in CCTV cameras for him, have a software, put internet on that CCTV system, and he can monitor it on his mobile anywhere he is, anywhere in the world. That's a classical example of Internet of Things. It can also be your car. Some cars have embedded systems, have devices within them, or have something inbuilt that you can connect to the internet. So you can link maybe your Ford or your Mercedes or your, what's this Elon Musk car again? You can link it to your mobile Tesla. You can link it to your mobile app, and you can check the car pressure, the tire pressure of that car. You can check the fuel gauge of that car even when you are not around.
Yeah.
So that is you managing, controlling, using, collecting data, sending data over the internet. So you call that Internet of Things. So that's your car. You can open the boot even when you are not around. Your gate, right? You can open the gate when you are not around. Somebody comes to deliver a parcel. Okay, your gate has IoT capability. So, okay, please, I'm at the gate. So there's a camera at the gate. You can also see the person. You can now say, okay, please, I'm going to open it, drop the baggage. I have my car parked by the garage and you can exit. Are you ready? The person says yes. So you open your gate, lock the gate. He walks in. You open your garage door. He enters. You open your boot. He drops it. You close the garage door. He exits and you lock the gate. That is Internet of Things at play, right?
Yeah.
IoT gate. Right? Even doors, right? With your phone, while you are not there, you can also lock the door. You can open the door. You can do so many things, right? Most gate entrances, your car, you can monitor car pressure, monitor car tire pressure over internet, right? Most apps, you will see something like this. You will see it on your phone. You can see the pressure of each of the tires, and you can now advise and say, okay, please just park and make sure, maybe is your child or your teenage or your wife or somebody that is driving the car. You can see the person that have flat tires. You can tap your app open and see how much and see whether it can go so kilometer if that place is not safe, and you can advise. So all of these things are application of IoT. So the internet has long connected people together, but in recent years, the explosive growth of the web has evolved connections between people and objects that they use. Now devices can measure soil push, moisture, noise, motion, air pressure, water pressure, typically anything, right? You can have an IoT device, a potentiometer, right? So this is how the guy is. You can connect it to an Arduino, and it's going to be able to measure the things you want to measure. It can be temperature sensor. So you can measure it and send it to the internet on an app. You can know what the temperature is over a period of time, and you can do forecast. These things are applied in agriculture, in healthcare, and in several other stuff. So that's IoT.
Okay.
So thermostats, lights, security cameras, door locks, voice-enabled smart speakers. So you can on your fridge, you can off your fridge. You can see how your fridge is doing, how much energy is consuming, how much is saving, at what volt is running, even when you are not there. Okay, so we are going to stop here for today. In next class, we're going to continue from what's it called? We're going to continue from 166. Install, configure basic wired or wireless SOHO network.